In this video, we'll look at how to use frame clocks with Molecule. So Molecule is a library that takes a composable function which returns some type. In this example, I'm using it to build a presenter, which returns a model. This library internally hooks up the recomposer. It hooks into the compose runtime and creates a state flow provided to you. So this library there is a monatomic frame clock. There is a monatomic frame clock also provided by Compose, and when it sends a frame, it kicks off a recomposition, and then a value that is produced from this recomposition, a new model is sent to the state flow. So how does this work? So we looked at how to launch a molecule. You create a scope and call the launch molecule method. So the scope takes in a main dispatcher. So the main dispatcher is a context coroutine context. So as you recall, you could add different things to a coroutine context. There are different things that are part of it, like job, dispatcher. You could also add a name. So for example, you could create a coroutine name, which is a context element, and use the plus operator to add to the scope. So the main dispatcher, what it is that in this library is a coroutine context, and there's an Android UI dispatcher. And what this class is that it's copied from the Compose UI framework, and it's copied from it because it's actually something which is general purpose, which is added to your context. So when you look at internally, what this main coroutine context also does is that it adds, using the plus operator, a frame clock. So the frame clock which is used, you can see it's an Android UI frame clock, which is also something which is copied from Compose because it's a general purpose tool. It's a monatomic frame clock which gets added. So when you look at what a monatomic frame clock is, just like a coroutine name, it's also a coroutine context element that as you saw, it's being added to your context. So when we look at this closely, uh, you'll see that when you launch a molecule, you provided a recomposition clock. And what I'm providing here is a context clock. And what this means is that we're saying that you should find the monatomic frame clock out of the calling coroutine context and use it for recomposition. So if you think about it, what is the monatomic frame clock that was added? As you saw in the previous code, there was a Android UI dispatcher, like a monatomic frame clock that was added, and it will utilize that. So what happens is that there are two types of recomposition clocks, a context clock and an immediate. Immediate is useful for testing. When you're without testing, you normally would use a context clock. So when you look at the launch molecule method, what it does internally is that it adds a empty coroutine context when you choose a context clock, because it's going to use the one that's already, because it's already added in the coroutine context as you saw before. So for immediate, you'll see that there is also a gated frame clock that's provided. And in another video, I'll go over more how what a gated frame clock it does internally. So what it does is that you can see it adds this to the clock, this clock context to the adds this to the context using the plus operator, and it provides it to the recomposer and this coroutine context. So that's what a little bit of what launch molecule does with when you choose a recomposition clock. So let's look at an example this library has, which illustrates more about significance of a clock and sending a frame. So suppose that one of the tests this library has is testing the ability to get items from the state flow. So I'm creating here a test coroutine dispatcher, and I also have a clock called a broadcast frame clock, so which is useful for general purposes and that the Compose framework provides. So we're going to add this clock into our coroutine scope, and we're going to add this to its context, the dispatcher and the clock. So then we're going to launch a molecule, and we're going to provide the context clock. And what this means is that what it's going to do is fish for the broadcast frame clock that we added already to our coroutine context. Is going to use that one. And the next thing we'll do is we'll have some state that we're updating, or we're going to do assertions on some value. So we also have, secondly, an emitter which we're going to pass in. So one of the launch molecule methods that this library provides also could take in some callback, like an emitter like this, which is called every time a recomposition occurs. And what I'm doing here is updating this value, this state. So in order to update this counter, we're going to have internally in this launch molecule method our logic. So we have our state holder for our account. We're going to launch an effect where we'll increment this counter in a while loop, and we have a delay before we go about incrementing this counter. And this launch molecule method, recall that it basically expects a composable function which returns some type. And in this case is a count, and we're incrementing it, returning it. We also have a delay before we increment it. So after that, we're going to do an assertion. The first of all, the value should be 0 when we start off. So the way this starts off is that the composable function is called, this logic is called, sets everything up, and the count is 0. It sets a launch effect and returns basically a count. So when we first go through the initial composition, the count value is 0. So the second time that we go through the uh, the uh, the loop, we need to be able to advance time because we have a delay. So using the virtual time clock, we're doing do advance time by. So what this does is that it goes in the launch effect, and then when it goes in this while loop, to go past this delay, that's why we're doing advanced time by. And that will increment the counter to another value, which is a 1. And that will be returned to the emitter, and the value will be updated. So the assertion is so we're going to assert that the value is 1, and what you'll find is that the test is actually going to fail. And the reason why it's going to fail is that even though it went through and recomposed, one of the things that didn't happen was that we needed to be able to send a frame. We need to tell our broadcast frame clock that we're using to send a frame. And when the frame is sent, and then when a recomposition happened, then it's going to basically push to the state flow. So the clock we're using is this broadcast frame clock that has a method to be able to that you could call send frame, and which takes in some number of milliseconds. So we're going to do clock.send frame, and this is just 0 milliseconds. And now our assertion is going to succeed. And and uh, and that's really really important to understand is the significance of sending this frame. I hope that was helpful to understand frames and how to understand how monatomic frame clock works. In the next video, we'll look at different ways to launch a molecule. Thank you.